Hello and welcome to our blood typing group assignment. I am Zane Small.
I am Berno Pieters.
I'm Aliani Swanepoel.
I'm Clarissa Griesel.
And I'm David de Lange.
I will start with the abstract. This report demonstrates the importance of blood typing through hemagglutination reactions between blood antigens and antiserums. Hemagglutination reactions occur when specific antibodies in antiserums bind to corresponding antigens on red blood cells, causing them to clump together, which is used to determine blood type. This reaction is then observed to determine a person's blood type according to the ABO and RH blood type systems. This information is essential for medical procedures, blood transfusions, and to avoid immune responses on incompatible blood in patients. In this experiment, a blood substitute is created using red-colored milk, and an coagulation reaction is created with milk's clotting reaction with vinegar. Anti-A, B, and D serum is tested with the blood to determine its type by observing the reaction with their respective antiserums. The patient in this experiment is determined to have the O-positive blood type. This procedure is simple and effective at determining a person's blood type and compatibility, and the experiment accurately recreates this procedure.
Blood typing is an essential procedure for medical procedures and emergencies. If a patient receives a blood transfusion from an incompatible donor, an immune response will activate and results can be deadly. The types of antigens present determine the type of the person. The ABO system determines whether the person has A, B, AB, or O blood, depending on the presence or lack of antigens A and B. And the RH system primarily involves the D antigen and determines whether the blood is positive or negative. A basic principle for testing blood types is hemagglutination reactions, the clumping together of red blood cells between the patient's red blood cells, antigens, and the serum antibodies. The presence or lack of hemagglutination can be used to quickly determine a person's blood type. This reaction will be recreated in the experiment below using dyed milk's interaction with vinegar that causes milk to separate into curds and hemagglutination to occur.
The methodology of our experiment is as follows. The instruments you'll need is 4 cups, 3 small bowls, 4 spoons, 1 permanent marker and tape. The ingredients you'll need is red food coloring, a quarter cup of cow's milk, 3 tablespoons of vinegar and water. The steps of our experiment is as follows. The bowls were labeled blood, anti-A, anti-B and anti-D, and cups, blood, anti-A, anti-B and anti-D serum. A quarter cup of cow's milk was added to the cup labeled blood. 7 drops of food coloring was added. A quarter cup of water was added to all cups labeled anti-serum. A spoon was placed in each cup. The anti-D serum bowl was randomly selected to add 3 tablespoons vinegar to. 2 spoons of blood was added to each bowl. 1 spoonful of anti-A serum was added to the bowl blood plus anti-A. This was repeated with anti-B and D serum. The reaction in each bowl was noted. A reaction has taken place when the blood agglutinates. Analysis. The anti-D serum formed clumps in our experiment. That means that the blood type in our experiment is O, because neither anti-A or B clumped up.
Vinegar was randomly added to the anti-D serum during the experiment. Blood in the anti-D bowl agglutinated. Blood in the other bowl stayed smooth. The blood tested O positive. According to the American Red Cross, O positive blood is compatible with all RH positive blood groups. We only receive blood transfusions from O positive and O negative blood. The clotting of the blood in the anti-D bowl demonstrates a reaction between the antigens of the blood and the serum, and it also shows the importance of blood typing. If this patient receives blood from an incompatible donor, his or her blood could undergo agglutination. This experiment demonstrates the effectiveness of a hemagglutination reaction and how crucial it can be during emergencies. No problems were encountered during this experiment and no recommendations for future experiments.
Based on results obtained in the experiment, it is crucial that accurate blood typing is essential for various of medical procedures. Now, One Life provides examples such as blood transfusions, pregnancy care, and disease prediction. Through the hemagglutination reaction observed in the experiment, the antiserum D mixture effectively illustrated that the sample of the person's blood type can be conducted, allowing the quality control for the patient's safety and optimal health care. The accumulation in the example also unravels the complexities of the immune response, offering insights that can lead to the development of initiative approaches for diagnosing and treating patients. This experiment was conducted successfully. Thank you for watching, and any questions are welcome.